Hello, everyone. Let's get started. Please download Laboratory 13 from Blackboard, and please use your Anaconda to open it. Today, we are going to continue introducing the NumPy package. As you see, it's a part 2 of NumPy package. Please run the first script to identify your hostname, username, and the kernel information. And the next one, please input your name, the R number, and the date, okay? In lab 12, we have learned how to define or declare the array variable and how to compare them, right? How to do the basic operations, basic calculations on the arrays. Into this class, we will learn how to manipulate these arrays and how to slice these arrays, okay? In the arrays manipulation, we will learn the copy function and delete function, okay? So numpy.copy function will allows us to create a copy of an array. This is very useful. We need to manipulate an array while keeping an original copy in memory. And next one is for the delete function. It can return a new array with the sub-arrays along axis deleted, right? So it is an example. You can actually index would be the row number and the axis would be the column number, right? So if you delete this axis 1, it will delete the second column, okay? That's why here you see there are only 3 columns after delete. After you do the deletion, after you delete the column, right? And next one, you can also use this 1, 0. It means you delete the second row, right? The index 1 means the second row, right? Because the index starts from start at 0, so 0 means the first row, right? So let's see one more example about the copy numpy.copy function. So first you need to define an array. And next one, you can define, you have 2 different ways to make copies on the arrays, but it's very, very different. So let's introduce you. The first one, you can use the assignment, right? The equal sign means assignment. So you can assign X to Y, but you can also use Z as a copy, Z as a copy of X. And next one is you can discuss the next one. You need to discuss the difference between Y and Z. And the last one, we show how to delete something. All right. So first, it's about how to define an array, right? You can use the numpy.array, and then you can use a list to define X, right? And after that, you have 2 different ways. You can define Y as X. You can assign X to Y, right? And the last one, step 3, you can use a copy. But for now, there are differences. So there are many, many differences. So biggest difference is that actually when you define an array, right, your system will give you a memory block to store this array, right? In this example, we have like a memory block. It stores 1, 2, 3 numbers as an array, right? And then it has a name. It has a name, or we can call it a pointer named X, right? That's why you use X. You can use X to find. Use this X. Use the pointer X to find the memory block, this array which stores this array, right? And when you use this assignment, it means you have another name, but the same memory block. So you didn't make a copy on the memory block. You just make the copy of the pointer. You have 2 pointers, X and Y, which point to the same memory block. Okay, so that's why here, this array is still 1 copy. But if you use the step 3, use this way, you can define another copy called Z, right? And then you make another copy of the memory block. So for now, you have 2 different blocks stores the same data 1, 2, 3. So you have 2, and the second one, the pointer would be y. So for now, perhaps you know the difference, right? But we will do more tests to show what is the difference. Okay, so next one, if we change something, if we change the index 1 means the second element, right? We change the second element of the first array, and then we check out the result. Okay, and you see both x and y has been changed because x and y they both point to the same block, same memory block, and but you have changed the second element, right? But for z, you have already make a copy. It's another block. So if you change x, it won't affect the elements of z, right? So that's why z hasn't been changed, but x and y, they are 1, 8, 3, but z is 1, 2, 3, right? Okay, so it is about the difference between y and z. So any questions so far? Later I will show you what is the last one.
I know exactly how bad it is for you, but it's too hard to care. Early childhood education is, I don't know, it's easy.
William, so do you have questions or can you repeat again? Okay. Okay, next one is about the delete, how delete the second element of x and see what happened for y and z, right? Y and z. So for now here, here we multiply x and y. We delete the second element of x, but actually it's different. When you use the delete y and index 1, it means the second element, right? So this one means you want to delete the second element of x. It means the first block, right? This block array, but you use y to store it again. So when you perform this code, it will create another copy, but this copy has only 2 elements. Okay, so for instance, because you have already used y to store it, and y is no longer pointed to the original memory block. So that's why here y would be 1 and 3, but here we can print out x and z again and show the results. Okay, you see x is still 183, hasn't been changed because after you perform this delete operation, then you make another copy and assign y to point to this memory block. Okay, and for z hasn't been changed at all. So that's why here is still 1, 2, 3. Okay, it's about how to understand the codes. And for now, you know, copy NumPy copy is a good function, right? If you don't want to make any changes or you want to keep a copy, you need to use it. All right. Next one is about sorting arrays. So sorting means putting elements in ordered sequence, right? You can put it in the ascending or descending order, right? And here you see you can sort it along the rows or along the axis or along the columns, or you can consider it as a 1D array and sort the flattened array, right? And I will give you one example here. So yeah, so this is a 1D array. So FIFA 2020 Red Dead Redemption and Fallout. This Need for Speed. So they are all video games, right? So we want to print that out and then sort it array in ascending order. Okay, so you can write, and the first one you print out is the original one, right? And if you use this sort, it will be ascending order by default. Okay, so it means you see it will compare the strings by the characters, right? And I think in your I think it's a little bit different, right? Because yesterday I add one more code. I add one more code to show you how to write code to the descending order, right? Descending order. Let me find it. I remember. Let me show. Let me find it. Oh yeah. So here is the descending order, right? I forgot to show it in my computer, in my styles. So next one is about how to sort them. This one is ascending order, right? It's ascending order. Next one is descending order. You can use this code, right? Yeah, but maybe for now you have a question. So how to compare two strings in arrays, right? So for example, here is a FIFA. The far out, they both start from F in their upper cases, but Y, the upper cases of I is smaller than lower cases of A, right? Because you need to compare it with the ASCII values. Let's check out ASCII AS2. Yeah, so it is a ASCII code. It about how to code the like the English characters into some numbers, because you know in computers there are only binary numbers, right? So we need to use the numbers to represent the like the different characters, like or different symbols, right? As you see here, 0 means the now symbol, and for instance, some like the double quotes, hash key, or and the round brackets, right? And 0 from 0 to 8, they are all code, right? But you see, 0 in ASCII is 48, it's not 0, and A is 65. So they will compare this value, all right? So you know this FIFA I for I, so we need to find I is 73, right? And the smaller and the lowercase a is 97. So that's why this for out is bigger than FIFA 2020, right? Because it will compare the characters one by one. The similar one for the fourth and the fifth one, right? You see NB, and the first character is the same, but the second one is B, and the need for speed is E, right? So that's because all the lower cases, they are bigger than the upper cases, right? Because they have different values. It's from 65 to 90, but the smaller one from 97 to 122. Okay, so that's why lower cases are bigger. Yeah, so it's just ASCII values. Sorry. So for now, you understand how to sort them, right? Run again. Okay, so any questions so far? All right, next one is about how to sort the n-dimensional arrays. It's a little bit different, right? Because it is only 1D array. You can use some similar functions in lists. But here is a 3 and 3 array. So 3 rows and 3 columns. You can use different ways. You can use another argument called axis, right? So A means array, but you can set axis as 0. 0 means in each column, right? So it is the original array, but and for the column, right? Because 0 is smaller than 17, than 86. So it's the first one, second one, the last one. That's why here is sorting, will be sorting in each column. For the last column, you see 2, 0, and 12. 0 is smaller than 12, than 2. So 0 is the first one, 2 and 12, right? And next one is sorting in each row, right? So axis is 1 means you only compare the first row, right? -6 it would be the first one, 17 would be the last one. And if you don't write any arguments, you don't give any numbers to this axis, it will be considered as 1 defaultly. So it means if you just use A, it will be sorted by default in each row, right? In each row. And the last one, if you set it as null axis, so it will be considered as a flattened 1D array, flattened array, and then only 9 numbers, and the one is a 1D array. Okay, it's about how to sort them in n-dimensional. Okay. All right. So any questions? Okay. Next one is about how to slice the arrays. Yeah, you can check the result here. It's similar to the slice principles of lists, right? We can do the slicing like this, start to end, and we can also define the steps. And then if we don't pass start, it will consider as 0. Don't pass the end value, we consider the length of the array in the division. If we don't pass step, it is considered as 1, right? And so using 1 is basically a 2D array. Yes, actually, this one, if you don't pass the number for the axis, it will be 1 by default. Yeah. But if you want to sort them in each column, you need to set it as 0. If you don't set anything, don't give any argument, it will sort in each row. Okay. Like this column, this line. All right. Does that answer your question? Okay, yeah. And next one is about how to slice. For 1D array, it's very, very similar because we learned how to slice a list, right? And it's exactly the same for arrays. Well, for 1D array, okay? So for instance, we create a new array. There are 5 elements from 1 to 9. They are all odd number. And then you need to slice the 3, 5, and 7. You need to use the start index and end index, right? So start index 1, it means the index 1 means the second element. So it starts from 3, and before the index 4 means the 5th element. So from second one, third one to the 4th one, right? So there are 3 elements, and give you the result. A slice. Okay. It's about 1D array. So next one is about n-dimensional arrays. In this one, we have 5 and 5 arrays. And we need to import. Actually, you only need to import the NumPy at the beginning. Yeah, because if you have already run it, it's located in your memory. So you don't need to import it again and again. Right, so good questions. But maybe in your weekly assignment, if you don't import it at the beginning, you need to import it in the middle. But you need to make sure if you want to use some functions in the array, in the NumPy, you need to define it first. You need to import it first, but only once, okay? Yeah, but here you see this one, we use this like magic words several times. If you use this one, it means it will clear all the definition, all the importation from the NumPy. If you run this cell, or if you run this line, after that you need to import it again. But if you don't use it to reset or clear the memory, then you don't need to import it every time. You just need to import it at the first beginning. Okay, is that clear? Okay, yeah. All right, so this is a last example. It's about how to get some slicing for n-dimensional arrays. So first one, you need to slice the first column and print out, right? So first one, we print this arrays, right? And the next one, because it's two-dimensional, so you have two different arguments right here, and then separated by a comma. And the first one would be the different rows you want to have, and then the second one would be the columns, right? So here is the first columns and print out. So first columns means the first element of each row, right? Right. So first columns to each row. So that's why here we set as blank. So blank here, when you leave it blank, so it will be considered as start from 0, and the end would be the length of the array, right? So here, actually, it's like it's exactly the same as 0 to 5. It means all the rows, but only the first column, but the first element, because you set 0 means only the first element of each row. So the first column, the first element of each row, it means the first column, right? So that's why we can use this way to print out the first column. And you see, it's a printout Superman from the Captain Marvel, right? It is the first one, and second one slash the third row and print out. So third row means the index 2. Index 2 represents the third row, right? And then print out. So it means you don't need to pass anything. So all the rows, all the elements in the third row. So that's why here you leave it as blank, only the column here. And then it is the third column, right? Third column. And next one, you need to find this word warfarin, and you need to find it first. So for example, here it is here, right? So it is the fifth row and the third column, right? Fifth row and the third column, but the index for rows and columns, they are both start from 0. So that's why the fifth row, third column would be 4 and 2 in the indexes, right? So that's why here is 4 and 2. 4 means the fifth row, and 2 means the third column. Just this one, right? And for the last one, you want to slice a 3 and 3 array. So from Wonder Woman to the Daredevil, right? So you need to find out the first one and the last one, their fifth row and the last row, right? Their rows and columns. For the Wonder Woman, it means it is a second row and second column, right? Second row and second column, second row, and the second column. And the last one here, this one would be the fourth row and the fourth column. Right, so that's why here second row means the index number 1, right? Second column would be the index number 1. So you set 1 as the beginning of the rows and the 1 as the beginning of the columns, right? And because the end index would be before the end index. So that's why the last one would be 4 and 4, right? It is fourth row, so the index will be 3, but you need to set the end index right after the this element, right? So that's why here is 4 and 4, because now it's 3 and 3, right? So that's why you can use this way to slice a 3 and 3 array. Okay, so it's about how to slice, do the slicing in n-dimensional arrays. Okay, so any questions? Okay, now it's a diagram, so we ask you to download it in the last lab, so you can learn different functions and how to use the functions in the labs, right? So, and the last one is about the exercise. Please modify the given code to do the following. Please slice and print the given array to look at this, right? This is the array you want to get, and then calculate the mean value the mean of the slice of array using the NumPy mean function. So the first one, let's check out. Reset the import NumPy. Define an original array, right? So it is like a 4 rows, five columns, right? And print out the array. And then please, oh, sorry, I think you don't need to modify this line. You only need to modify this line to input some numbers to do the slicing, right? You need to figure out what numbers you should put here to get this array, right? And then print out this array. And after that, you need to calculate the mean value of the slice of the array. This one, if you forget how to get it, you can check the lab 12. Lab 12 and this example. So n-dimensional arithmetic here is about how to use this function. Okay, so I can show you. You can put NumPy mean and the value here. Okay, and run again. Yeah, so you need to import this one, right? Import this correct value. So in other words, you only need to modify this line and this line. So only two lines of code. Okay, to make sure you print out give the required sliced array and calculate the sliced array, the mean value of the sliced array. Okay, it's about the exercise, and yeah. All right, so that's all I want to share today. If you don't have any other questions, please feel free to leave the meeting, and have a nice day, and see you on next Monday. If you have some questions, you can stay here and discuss. Thank you, guys. Thank you. Thank you. Like orders where was last thing? Okay, sure. This one, right? Yes, first I will answer your question. So yeah, all you need to do is run the cells and finish the last exercise. Yeah. How the brackets are working? Yeah. So yeah, actually, the square brackets you see here, because it's a n-dimensional array. So that's why it's not. First of all, you understand this one, right? This one is use the square brackets and to get the start index and to the end index, right? It's only for 1D array. But for this n-dimensional arrays, because you have the rows and the columns, so you need to have two different numbers, two different slicings separated by the comma. The first one is used to slice the row numbers, how many rows you want, and then second one is how many columns you want. Okay, so for instance here, it means you want all the rows, but only the first element. So I mean the first element of all the rows. So that's why it's the first column. Okay, and for this one, then you need to figure out how to find the index of this because they are all like the squares, right? They are all squares. So you need to find out the first one, like the upper left corner of the square, and find out it is its index, and put it as the first row, as the start index of the row number and the start index of the column number, and then find out the end index for both of them. Okay. Yeah, because it's an n-dimensional. That's why you need two different arguments here. Okay, but for 1D, so you only have one. So that's what you'll learn for lists. Okay. So does that answer your question? How we are okay. So here, if you don't use this column, it means you only want one column or one row, right? So this 4 means we want the fifth row, right? We only want this fifth row. First, we use 4 to represent the fifth row, right? And then 2 means we only want the third column, the third element of this row. So that's why the first one, the second one, and the third one. So that's why you can get this only buffering from that. Okay. Only one element. Yeah. We only print the entire. Yes, exactly. Yeah. Because here you see, we show it here. So if we don't pass this start and end, we don't pass this start, it will consider as 0. And we don't pass the end, it means the whole length. So it means if we only have this column here, it means the entire rows. Yes, thank you. Yeah, good. Any other questions? Okay, I think I will stop here and see you on next Monday.